And here we go. We have liftoff. Propulsion continues to be nominal.
R68 chamber pressure looks good.
Hey everybody, it's Lon Seiben here with NSF, and we are live because Booster 9 is getting lifted as we speak. It's a very busy week here for space exploration, and I'm very happy that we have some experts here to let us all know what is going on right now down in Texas. I want to introduce Adrian Beal. Hello there, Adrian.
Hello, everybody. I'm glad we get so much Starship action right now. It's always fun to see so many streams in one day.
It's amazing. It's keeping us all busy. I know that the chat's been wild just trying to find people. And Chris Bergen is here from across the pond. How are you?
Good evening. Yes, exciting times. Finally back into a bit of a pace now. I think we can start getting a little bit excited about a launch coming up, providing the static fire goes well and I get to full stack. But it's happening. We're getting there. We're getting a full stack soon.
It is. We got a booster that's getting lifted. It's got some weight on those chopsticks. So, Adrian, what are we looking at right now?
Yeah, so we are looking at Booster 9 already inside of the chopsticks, already being lifted. So that's what we already see is basically it's still in these guide rails on top of the transport stand, but it's already being lifted on top of his transport stand. And yeah, the chopsticks are already carrying the weight of the booster. It's basically in the air, and we are just waiting for it to speed up its ascent and then rotate over to the orbital launch mount and then gently be placed on there without denting any raptors. That's the goal.
That sounds like a very intricate maneuver to not dent any of those many engines that are on the bottom of that. Is this something that's controlled manually, or is there a computer guiding them in this?
The expectation is that there's absolutely some sort of guidance computer for doing this. I cannot imagine there's like a person with like a joystick or something doing this. So yes, it's probably guided by multiple tools, and there's also guide rails. For example, on the stand, I'm not sure if we have the close up ready yet, but there we can see guide rails there that basically make sure that this booster doesn't touch the stand while it's being lifted, because of course there we can see it. You can see them on the left and the right, how these guide rails have the booster while it's being lifted, so these Raptor engines are not touching the stand while it's going.
And what's funny, I've been down to some of the shuttle launches where they had the retraction of the RSS structure, right? And it would take half the night. This seems like it's going a lot quicker, even though we've got a lot more going on here hardware-wise.
It's that shuttle, so that's already a bonus point.
Yeah.
Yes, it's usually we expect this lift to last maybe in like less than an hour is even possible, depending on how fast they go. They have multiple places during the lift where they usually hold a bit and probably inspect and see if it's like shaking and anything. We also had, to be fair, aborted lifts in the past where they had to place it down again. The most notable one was a lift of Ship 24 before the launch, where apparently there was a cable dangling around, and we saw them placing the ship down again and removing that cable. So there has been some lift aborts in the past.
Well, it looks like it's making some pretty good progress here. And I want to thank Troy Rubert. I'm going to put him up on screen here for gifting 20 Red Team memberships in the chat here. Thank you very much for your support. I can't tell you how busy this team is right now. It's incredible how much we've got going on. We got Crew 7 coming up. We've got all this activity down at Starbase. There is so much. So definitely keep following us here, because there is going to be a lot of content on the way. And I want to thank also Jeff Rowe for gifting 1 Red Team membership. So what, they had one launch. We saw the damage that took place on the surrounding area from that one. We've seen water deluge tests to try to rectify some of those issues that they had on the first launch. Is all of this activity and the rumored test launch coming up very shortly an indicator that they're confident that this new system is going to prevent some of the things that caused some issues on the first launch?
Ooh, I would say, yeah, they're probably at least confident, like they are confident it works. It, of course, to be fair, if we look at the test campaign of the first flight, everything looked well as well at the static fire stage, because that was not a long duration static fire. That was not something that fired at 100% thrust. So everything kind of looked good up until the moment where the launch happened, and then we saw concrete flying. So I guess they're in the stage where they're like, we want to test the system, and they wanna validate what they've built. Although based on what we have seen, I'm pretty confident that the deluge system will at least have some sort of impact on the overall potential damage of this system.
It was really cool to watch that water deluge system in action. It's definitely unique. It's certainly not something we've seen on some of the NASA rockets that we've watched so many times here on the channel. So this is cool. All right, so it looks like the booster is completely off the stand now, and the stabilizer pins are next. And what about these stabilizer pins? Why are they important?
Yeah, if you look at the top of the chopsticks area, you can see these small little arms below the chopsticks. These are basically there to stabilize the booster on more than one point. Because if you imagine holding the booster just on 2 points on one axis, like they would without these stabilizers pins, it could basically go back and forth, right? You would not block that motion. But if you put in these stabilizer pins, you stabilize it not only on a vertical, but like on a vertical line, basically. And that's how you make sure that booster is not suddenly starting to wave around in the air, because that's the least you want. You don't want this 70-meter tall booster to start moving around while you lift it.
Yeah, that would be a very bad thing. And then on top of that, when you have the whole stack up on that launch mount there, it's certainly something that is rather needs to be pretty stable to have that thing support all that weight. And it looks like we have another expert joining the call today. Ian Atkinson is here, I think.
Hey.
I see it. There he is.
I am here, Lon.
Okay.
How are we doing today?
We're doing great. We're watching a booster not lift off the pad, but getting lifted onto it. So that is the order of events this evening, and it looks like it's making good progress. We're starting to see some of those engines now, aren't we?
Yeah, it definitely looks like some slow but steady lifting there. You can see the Raptors beginning to peak out. A lot of their test instrumentation and some extra piping and cabling on there. But yeah, definitely a good sight here to see Booster 9 roll out for hopefully the last time, if everything holds true here.
And if so, I can, Lon, I'll just quickly add some context to this as well. Booster 9 aft should look slightly different compared to Booster 7. Booster 9 has got hundreds of modifications compared to Booster 7. So it's an important milestone this, that not only do they get through the campaign, the pre-launch campaign faster, with less issues than Booster 7. Let's face it, Booster 7 had some issues. But also that this...
Sorry, Chris.
Carry on.
Stabilizers are moving in.
Okay.
I'm sorry.
That's fine. But yeah, it's an important point to make that this flight is all about booster performance. They need to try and find that their modifications of Booster 9 have vastly improved on what they suffered from with Booster 7. And if that all goes well, regardless of what Ship 25 does, because it is about the booster this flight, then they could be rolling out Booster 10 in a matter of weeks, and then we'll see another reduction in the processing flow towards launch. And that's all part of SpaceX's primary goal here, is to make it rapidly reusable. Not just reusable, but rapidly reusable. They want to be launching these things 3 times a week, apparently, within a few years. That's where we're heading with this.
And of course, Artemis 3 is going to depend on that rapid reusability for that massive fueling campaign that has to take place in orbit, right? So it's going to be necessary. And that's going to happen from Cape Canaveral, Kennedy Space Center?
Yes, most of the HLS program, which is Human Landing System for anyone there, that's the NASA contract SpaceX has got. The whole reason why they've built a tower at 39A, and they will likely build 2 towers at LC-49 and maybe even one more on the Space Coast, is because KSC will be the primary launch site. Starbase right now, well, they can change, Starbase right now is their development center. They have a permit to launch about 5 times a year. They can again change that. They could have a second tower at Starbase. that might happen in the future. These are all things that they can apply to it once they learn from what they require. But the big bulk of the HLS missions, such as refueling, will be from KSC.
So we're going to have a lot to cover, I think, in the near future. Hey, we got a couple of super chats coming in here, and I want to take this one because it is a question. I'll put it up on screen here from Douglas Springer for anyone that wants to get this one. It doesn't appear, he says, that Chopsticks are making contact with the grid fins. How is the booster being lifted? You know, as I was watching, I was about to ask the same question. So anybody care to fill us in on that?
Yeah, so I'm not sure if we can move it up a bit. I'm not sure if that's an angle we have right now, but the Chopsticks, that's a misconception I think that a lot of people might get when seeing these lifts. They are not lifting on the grid fins. They are lifting on small lifting pins that are just below these grid fins, and that's where the chopsticks attach to this. The reason probably being that you need a lot of attached machinery that you would have on these grid fins and everything. So you would put a lot of stress on this area that you probably don't want to do. So you have these small stabilizer pins where the chopsticks connect on it's not stabilizer pins, lift pins, and that's where they lift it. They're not lifted on the grid fins. That would not be good.
Yeah, it's probably not something you want to have putting that much weight, right, on something that is important for aerodynamics on the way back down. And unlike what we see with Falcon 9, where those grid fins kind of come out when it's time to use them, on Starship, they are always extended. Is that right?
Yes. They always stay extended, and they will move a bit. They will always help a bit to guide, but they cannot retract like Falcon 9. They cannot move down on the vertical. They can just move, they can rotate.
And Lon, actually, I'm sorry, go ahead.
No, please.
I was going to say, when Adrian was talking, it actually brought up a bit of a memory from about 2-ish years ago, when Elon was first discussing the whole catching concept with the chopsticks and stuff. He did say they were going to catch it via the grid fins. So I assume it meant the grid fins were going to be load bearing in some way. However, obviously SpaceX has opted not to go that route, probably because it would have meant the grid fins would be much heavier. The motors would have to be upgraded to, withstand the 200 tons of the booster's dry weight. So yeah, in this configuration, at least right now, you do not want any load being applied onto your grid fins. Those are not load-bearing grid fins.
So that is a good point to know. So, and it was funny because I remember seeing a lot of those mock-ups of the grid fins kind of being what was getting caught. But it looks like certainly there's some other load-bearing features here of the booster. And the plan was for the first launch was to basically ditch it in the ocean. We have to get to orbit first before we can even think about trying to land one of these boosters, right?
Yeah, absolutely. Okay, go ahead, Ian.
Go ahead. I was going to say it's going to be probably a minute before they start trying to do a return to launch site here. I mean, it could happen within the next few launches, but I think the main objective right now is let's get something orbital, then let's figure out how to reuse it, similar to Falcon 9.
There's also an interim step as well, where if you remember the Falcon 9 landings, the first ever Falcon 9 landings involved no drone ship. They brought them down for a propulsive landing on the ocean and used a pinpoint method of working out that they could bring them back to the drone ship with some accuracy. So I would fully expect that the first boosters that do go orbital, they'll bring them back and try and do a soft water landing with them and just say, well, we'll pinpoint this area in the ocean. If we get close, we know we've got the accuracy, and then we'll start bringing them back to the launch site for catches by the chopsticks.
And I want to also bring up that we've got some merchandise, everybody, while we're waiting for this lift to occur. And one of the awesome things that you can find on the NSF shop is a beautiful picture of a night at Boca Chica printed on metal. And you see the entire Milky Way, and I'm assuming in the distance there, Starbase lit up. Kind of a forward-looking future of space exploration, and it's available right on the shop for you.
There it comes.
Yeah, I was going to say, let's show it on the screen.
It's by Sean, and it's absolutely amazing. I think everybody who saw this picture, once he posted it, we had multiple people that instantly went I want this on my wall. That was a general consent, and we just wanted it. So yes.
This is one of those sites that I put on my wife's computer for holiday gift hints, right? So so that's something that might be done there. Hey, we got another 20 red team memberships gifted from Apocalypse Cow. Thank you very much for your support of the team here, who is working extremely hard to bring all of this content to you. So we appreciate your support
on.
for sure.
I think Patrick's doing a pun there in the store. When Patrick likes to write puns in the store messages. That's something you can do if you purchase them from the store.
Oh
You
my
can actually put a
God.
message that we'll read out in
Wow.
chat. Hopefully not the level of Patrick's puns though, because he's stealing Sawyer's
Ooh.
pun tokens there. Look at this. Here we go. How does NASA organize its rocket launches? They plan it.
That's not even the
Ooh.
right tense of the word.
Ooh.
Patrick needs to read the style guide.
My kids love puns, so I'm going to use that one later. All right, so it looks like so the stabilizers were going in, or where are we at right now, folks? Where do you think we are, Adrian? What do you think?
Yeah, the next thing, so you can see at the bottom still that these bottom stabilizers are still out. With the transport stand pins, and the next thing we would expect is these to retract, and from that on out, the booster is basically released at the bottom, right? So that's when they really start to pull it up and then transition it over to the pad. So yeah, we expect that the next thing to be that these retract and then the actual lift to happen. They're still in the phase of like stabilizing it, securing it. It's more a really pre-lift phase, and then once this is all done, they will really move this fast.
And how do they now after it gets lowered down onto the launch stand? How do they secure it? Because it's going to obviously stay there for several days, if not more. What's the stabilization process that they use there, Ian or Adrian?
Yeah, so on the orbital launch mount, they use 20 hold downs. Now these are not super huge hold downs. They're spreading the load across 20 of them. These are also the same hold downs. Well, these also do play into the Raptor boost engine startup. So you have 20 hold downs on the outside, corresponding to 20 Raptor boost engines on the outside of the booster. So the thing is, when they lift the booster in, those hold downs need to be retracted to give clearance to the engines coming down. Once the engines make it down past where the hold downs are, the hold downs retract out. They kind of go inwards on the ring of the orbital launch mount, and then they drop the booster down just a little bit more until they're resting on those hold down points. Then there's a small platform that kind of goes down and holds down the booster on those hold down points, and then from there they can attach the quick disconnect and do any other work that they need on the vehicle.
You know what's
And
funny, Adrian, when you look at this.
I'm sorry.
Go ahead. Yep.
I believe if we can go closer, the pins are going down now. The transport stand pins. You can see it at the bottom there in this view. They're now going down slowly, as the booster is basically being released at the bottom.
So we're making progress, it seems like.
Oh, absolutely. So far this looks like a picture perfect lift.
Yeah, we instructed Pony Cam to have a close look. Oh, it's Horse Cam actually.
There it is. Yeah, you can see how they go down.
Yeah.
Very
neat.
cool.
It always looks so small if you go in these wide shot totals, but then you go close and you're like, yeah, this is huge hardware.
Yeah,
Yeah,
it's funny. You don't realize how big this stuff is until you see it in person. And I started covering space on my own little channel about 12 years ago or so. And it was just amazing to me where you know that it's big, but when you see it and look at it with your eyes and realize just how much goes into this, effectively taking something the size of a skyscraper and sending it into orbit it's just mind blowing that we have figured out how to do this.
Yeah, well, the first time I drove, like I was driving down, or like, well, I was driven down Highway 4. The moment you realize that you see the rocket there it's amazing. It's breathtaking.
Wow.
And wow.
There we go.
Look at
That's quick.
Wow.
So there you go.
She
It's moving
goes.
upwards. Now, one thing that's interesting that I'm noticing here, the engine bells have covers on them.
Yeah.
You could see
Booties.
on the
Yeah.
right, the ones they're pretty loose. So those definitely seem like, carpets they had lying around. They ran out of actual covers.
Right.
But it looks like the center and leftmost engines there have like dedicated nozzle covers or engine bell covers. We've seen similar on Falcon 9 with the Merlin engines, but I don't recall seeing any covers like that for Raptor. Those like, really good fitting covers.
Mm.
Definitely,
Rocketdyne had them. Rocketdyne had them for the space shuttle. When the orbiters would roll over, there was two parts of a space shuttle processing flow. It was roll over to the VAB and roll out to the launch pad. And during rollover, they would have them covered in these 3 booties, big red booties, and that's what they called them, the booties. So that's sticking with me now. I'm staying with it for Raptor. I'm calling them booties.
We'll
No
take it. They're going to
objections.
be no objections. So ordered. And I think maybe they learned a thing or two from Tesla. I was watching a truckload of Teslas get delivered the other day, and all of them had some protective stuff on their hoods to prevent damage. So it's a good thing to have some protection on those valuable engines. We don't want anything happening to those on launch. So what's next, gentlemen? Adrian or Ian, what are we doing now? We're holding here for a minute, and then it's going to keep moving.
Yeah, sometimes they tend to do these little holes where they probably check out if everything is still good. Like you don't wanna go too fast, right? You can make quick holes, and once they do resolve this hole, usually they go up almost all the way where they can transition over to the pad. So I expect once they move again, this will move up high, and it's always looking so crazy, right? It's just a tower holding a booster.
Yeah.
It never looks normal.
It doesn't. And I think that's what makes this so exciting is that we're engineering that just goes into this. And when you think about rockets and rocket science, there is of course the rocket science, but there's also a tremendous amount of just basic engineering, structural engineering, and to get these rockets just to where they need to be. Ground systems are really important. Hey, we've got a super chat here. Let me put it up on screen, and we'll take some other chats from the chat room as I look through here. The chat goes really quickly on these streams, gentlemen. So Booster 9 entered Highway 4 about 6 hours ago. I think they are going for a record time for transport and mounting on the OLM.
They might be, although I will fully admit that I have not have the timetable of previous lifts, everything ready, but this feels very fast. Like
Yes.
from rollout, the rollout was fast. They basically instantly went between the chopsticks. I wouldn't be surprised if this is a record. Yes.
Yeah, many times they've actually had the booster sat on the cryo station, waiting to be moved to chopsticks, and in between SPMT lifts and things like that. So this is the first time I think I've seen it rolled straight into the into the chopsticks and then grabbed. By the way, on the chopsticks, the Mechazilla system, we thought Elon was joking when he first mentioned it. It wasn't long after he'd mentioned the bouncy castle of recovering dragons, and then suddenly comes out, oh, I'm now thinking about putting these big mechanical arms on the tower to catch the booster and ship. And we're all like, yeah, all right, Neil, yeah, we're not going to fall for it a second time. And lo and behold, they start fabricating these massive mechanical arms and start attaching them to the tower. So it is baffling, but we've become used to it almost like now, but no one else does this. Nobody else does this.
And Ian, when I think about SpaceX's development, and you think of how many times we have watched starships explode or get severely damaged, that's the process, right? Like this is how they do it. Artemis obviously
Can
had to
I
be
quickly interrupt here? Sorry.
Oh, sure, go ahead. Yep.
This booster is starting to rotate a bit. It started to rotate away. So basically, it's right now doing a horizontal transition a bit instead of a vertical. So it's now being moved a bit closer to your LM. It will then be lifted upwards. Just interrupting you because it was happening right now.
Hey.
Go ahead again.
That's fine. We're here to watch this, so it's good to know when we have some milestones happening here. But Ian, on that point, just the fact that this development is so much trial and error as opposed to the very low risk development we've seen with some of the NASA rockets, right?
Yeah, that's basically been SpaceX's mantra since day one. Whereas NASA is taking more of a conservative, slow and steady, and then we do an all-up test when everything is ready. Like we saw with SLS and with Orion, SpaceX is kind of just slinging mud at the wall and seeing what sticks. And there's nothing really. NASA's system isn't worse. SpaceX system isn't worse. They have their pros and their cons. But SpaceX's mantra, and a lot of the mantra of new space companies nowadays, is just to test as fast as you can, learn when things explode, and just make your product better for next week when you test it again. That seems to be the direction the industry is going in, and SpaceX has absolutely been pioneering that over the past few decades.
It looks like the rotation has stopped, so I guess next we will expect to see some lift going on here.
Hopefully. I mean, I don't recall seeing a rotation like that before, but it definitely seems like they're getting it into as close to the OLM as they can to minimize the rotations when they're way up in the air.
Right, you want to keep that super stable. Crush Media with a super chat here. And let me click on my button here. There we go. How likely do you think S25 will reach orbit? I'll have Adrian take that one. And we've got some movement.
Yes, it's going up now. Oh, good.
There we
going
go.
up fast.
Yeah.
Wow. They're really moving
Moving.
fast here.
Yeah. Not as fast as it would if those engines were going.
So do the center engines have the good cover, the fully applied cover, or will they have the right one, the more loosely applied one? I'm wondering.
They probably literally just found like some packing fabric, and they're like, good enough. Just tape it on there. Let's go.
Yeah, right. Let's get it up there. We got a schedule to meet here.
But I do like your idea, Lon, of a Raptor assisted takeoff. I think they could get this up on the pad in 30 seconds or so.
Yeah, they had that hopper, right? They could hop it right on there.
There we go.
By the way, related to the question, I think that's a good question because there's context required here. There's expectations to set. We all were asking about if Ship 24 would make Hawaii, and we're all cautioning. In fact, Elon Spaces, I asked him, I said, look, if we get to max Q, I said we as well, by the way, as if I was part of SpaceX, it's quite funny. If we get to max Q, that's a win. And he goes, absolutely would be a win. And he achieved that. There was people expecting a splashdown in Hawaii and seeing how TPS performed. I think that was asking way too much for the first flight. And I think it's asking too much for the second flight, to be fair. I think this is all about Booster 9. Ship 25 is not modified. Ship 28 is. So if this goes well with boost performance on Booster 9, don't worry about Ship 25. If it stages, brilliant. If it doesn't make Hawaii or it goes AWOL during its second stage firing, which is what the second stage is, it's Starship, then don't worry about it too much. The next test with Booster 10 and Ship 28, we think it's Ship 28, will be the big test of where we start expecting something from Ship. It's all about baby steps, really, with this program. It is the world's most powerful rocket by a factor of 2. This is not going to be easy.
No, and you have a lot of systems that have to work in concert with each other to make all this work. We have a great camera out there. How far away is that camera?
I would actually, I would say about 400, 500 meters, maybe less, 200, 300. I'm very bad at guessing distances.
Okay. Were any of you
probably
out
less.
were any of you out at the first launch of the full stack?
Yes, I was. I was,
What was-
out there.
What was that like from a sound perspective? Because I've now seen Shuttle, I've seen Artemis and a Falcon Heavy and a Falcon 9, which are all pretty loud. But what was it like to feel a Starship liftoff?
I was about 5 miles away on the roof, and it was loud. Like, even there, it was very, very loud. I heard from other people that apparently SRBs just hit differently. I think Jack explained that to us a bit. But overall, it was still very, very loud, and you could really hear it moving a lot around. And of course, I have to admit that at some point during liftoff, you lose complete track of what is exactly happening because you're so excited and you don't really remember every detail.
Right.
But it's insane.
And we've got a super chat here from Michael Oliver, who suspects that the loose covers are moving blankets that are used for furniture. So they probably just grabbed them out of the U-Haul. It's got them on there, right? Well, hey, if
Exactly
it works,
what I was thinking.
it's good enough for your, for mom's furniture there. It's probably going to be fine for that.
Good enough for government work, as my dad would say.
That's right. And Matthew Azarito with a super chat. Let me pull him up here. How long before you think a fully rendered Starship with cargo bay and crew cockpit will be built? Thanks for the great work.
Oh,
They're going to focus first on. Oh, wow, we're really high here. But I'm guessing they're going to focus on just getting this thing off the ground and into orbit first. And I would imagine the interior is probably a lot easier, right?
Yeah, I mean, we know that they're working on it simultaneously, of course, with their that they need to do it for NASA. And also we saw Ship 22's nose cone roll out a few days ago. seemingly having like a door on the side of it. That may have been an HLS mock-up. I mean, even then, there was literally HLS scribbled on the side of one of the pieces of it. So we know that they are working on it simultaneously, but it definitely seems to be a little bit more of a back burner project compared to Starship proper. Like, of course, they have teams working on, I'm sure, the life support systems, the elevators, the displays and seats and stuff. But, you know, the majority of their effort is, let's get a working system that we can then put that life support in. So I feel like they're definitely going to start to shift priorities towards payload launching and then crew launching as the Starship evolves and becomes more and more successful. So it's probably a few years until we see even like, you know, hintings of a full-scale crew Starship coming about.
And it looks like we are now up and now going over. Am I seeing things correctly here, gentlemen?
Yep.
Definitely.
They're not even taking breaks. Like, correct me if I'm wrong here, folks, but this seems, even for their standards, this lift is fast.
Yes.
Like, wow.
And it goes
We're gonna
back
have
to a question that came up earlier. Is it controlled by a person or by robotics? It's a bit of both. I always like to joke that it's Elon in a control room with a PlayStation controller, just saying,
Yeah,
this is
right.
my fun day. I get to move the booster around. But no, it is basically, they've got cameras everywhere. They've got laser systems apparently as well. But there's a computer screen. We've seen a screenshot of it. I don't think the person who's posted it should have posted it, but it's basically a very clever computer screen, and there's a controller involved with it. So it's, as Adrian was saying, it's a lot faster than normal. So they're learning each time to do this. They're learning something new. They're learning how to make efficiencies, and we're seeing the product of it now.
I like to imagine they're using a WASD and then shift and control keys to move everything around.
That's, oh God.
At least
you
they're
need
moving
to
it
have
better
those-
than when I move cameras. When everyone goes, "It's Chris doing a tour of the camera because it's jerking everywhere," that's definitely me.
And I got a question here from the chat. I'm trying to pull out more chat questions. They just come in so quickly. But Scott Grizz was wondering, any estimates about how fast this is moving? It seems to be, Adrian, that this seems to be moving a lot faster than you've seen it move before.
Let me give me a second here to do some very rough pixel counts.
Got it.
And I think we can give some estimation here. Give me
Alright.
give me a second here.
All right, well, while you're
If I
crunching the numbers
had-
there, we're going to take a super chat question from Kaltenstein, who wants to know, would a crew Starship even have something like the shuttle's flight deck? They don't need to glide it like an airliner after all. I guess, right, most of it would be autonomous, right? Do you need a flight deck?
Oh, that's a good question. That is a good question, because we've not seen any official internal renders other than the initial BFR days, the ITS days, where they showed a violinist floating around at like a
Right.
concert, and there was nothing as control panels or anything like that. I fully expect it to be automated, just like the Polaris mission's going to be. With Dragon and like Inspiration 4 was, they obviously were trained. They could have taken over, and I'm sure there'd be somebody on board who could take over in the event of a computer malfunction. But I'm sure the progression of this will be automated. That is the future of this thing, and I don't think it'd be anything like a shuttle flight deck. I mean, Lon will know. The shuttle flight deck was like a Christmas tree of lights and controls and panels, even with the glass cockpit. It was just complete nightmare to learn all of that system. So I think it'll be along the lines of a step further from Dragon, where it's like a few computer screens. I think it'd be
Right.
touchscreen screens, and that'll be it.
I was
mean-
very fortunate to be able to go on a tour of Discovery's flight deck when they had that media thing going on at the at Kennedy Space Center, and it was amazing just to see how much it really looked like, you know, what you would design something in the 1960s to have. Just
Yes,
a lot of
yeah.
gauges and dials and switches, and you flew it, you know, in the atmosphere in the front, and then in the back you had your space stuff. It was very well delineated between your flight modes.
And Chris, don't forget, we have seen pictures of crews training on Starship or HLS touchscreens. They seem to be very much derived from Dragon's not
Yes.
only user interface, but also the physical screens themselves. So we really don't know how manual it's going to be. I would be surprised. I would not be surprised if the system was fully automated from gateway undocking to landing at the lunar South Pole. But I would imagine NASA would absolutely want manual override for all stages of flight on HLS.
Yeah.
So it wouldn't surprise me if we see a large amount of kind of derivation from Crew Dragon setup, as in literal maybe Crew Dragon seats and displays and other hardware.
We're going to have multiple starships, right? We will have crew starships. We're going to have fuel tanker starships. We'll probably have cargo starships. We'll have Starlink launching starships, right? There'll be different types of vehicles that follow the same.
We did a video on that.
I was just about to say, yeah.
Hang on, I'm gonna spam chat. This is where I can show off my powers of moderation
Oh,
by
right.
literally not having Nightbot say any problem at all about me doing this. 1 second, I forget the right chat. I'm back in Starbase
Alex
Live.
beat you to it. Alex beat you.
Oh, there we go. Fair enough, Alex.
I wonder who
Alex.
wrote that video. He must be very talented.
That is a good video. I really enjoyed that video. So if you've not seen the Starship variants with Ryan hosting it and Alex wrote it, please give it a watch, especially after the stream, because it is a cracking video. It's a really good video. And it really explains the amount of versatility involved with Starship. I love this vehicle, and I'm not ashamed to say that as a journalist. You're meant to be all, you know, you're not meant to sort of like have favorites, anything like that. But I think this vehicle has so many applications, and not just in low Earth orbit. This is a beyond Earth orbit vehicle that's going to take us to Mars and beyond, that you can only root for it. There's no reason to root against it. I just don't understand, you know, why anyone would want it to fail, other than probably people who've got a problem with Elon. But again, this is about humanity, and it's an incredible amount of capability that we're bringing onto the table here.
And I tell my friends when we're talking about space, I try to talk to them as much as I can because they're not as into it as I am. That Starship is required for a moon landing to happen. It is part of the plan.
Yep.
And I think what's neat about Starship is that it's not designed for a single purpose. It's designed for multi-purposes, and that's good in a space vehicle, I think, especially as we're as a species, we want to spread our wings a little bit. So it's good to have something that can help us do that. It looks like now we are over the launch mount. Am I correct in my observation here?
Looks like we are either just about over and doing alignments or pretty much over it. Now we know that they're going to be doing some minor adjustments here and there with the chopsticks, you know, swinging it back and forth a little bit, rotating it a tiny bit to get it perfectly aligned. And then we're going to start to see the descent there. Again, that section there is likely automated, but we're going to have to get a zoom in there. And if you do a time lapse of this segment here, you'll see it start to slowly wobble a little bit as they perfectly center it over the OLM ring.
So they have a lot of ability to make some fine adjustments here, Ian, huh?
Yeah, they really do. They can swing it, forward, backwards, rotate it side to side, translate it side to side a little bit as well. Quite a bit of wiggle room, and you need something like that because this is a very, very big and expensive object, and you can't perfectly line it up every single time just using the raw chopsticks alone.
And we got some super chats piling up here, and I want to take this one first from Matt PD because I had a question about this also. First of all, I can't wait to see the jack pick in the morning sun reflecting off the RVAX through the hot staging ring. And the hot staging ring was something that I was planning to ask you folks about. Maybe we'll have Chris field this one. The hot stage ring, is it on top of the booster right now?
Yes, it is. And we're trying to work out if it's clamped on or welded on. We think it's clamped on because we saw it being raised in the mega bay and then installed on top of booster 9. And before we know it was there. We didn't see any welding, the obvious sparks we get from the orbital launch mount. We didn't see any of that. I think it's going to be fascinating because they've done some testing with it at Macy's with the Booster 11, as it was classed as a test article, and apparently it passed and everything's gone right structurally, and that's when they went, okay, let's install Booster 9s and roll it out. It's going to be a fascinating thing. It's all about never stop thrusting, as Elon called it. He wants the idea that staging does not lose some velocity or some thrust because they can keep the booster firing with, I think, 3 engines, while they're firing up Starship's engines itself, and the fire will come through those holes there, as we're looking at it right now. Literally, we'll see in a very impressive sight at staging, and that will continue on with the flight. And basically, that is the whole purpose of it, is adding more capability just for that little ring. But also, the important thing is they've raised the ship quick disconnect arm because that is now higher on the stack where Starship will be placed on it. And it is literally going to be the tallest vehicle ever because it beats the height of Boost 7 and Ship 24. It's
Right.
gone a little bit taller.
A little bit taller. And I guess with all that weight that you're trying to boost to orbit, having any stoppage of thrust is probably not as good of an idea, perhaps, than it is on lighter rockets. So it kind of eliminates some risk to just fire and keep going, right?
Yeah. I think we've got an image coming up soon on the live stream. We'll show how they've applied the changes to the ship quick disconnect arm I'm just waiting for it to come up on the screen. I've seen a camera move towards it.
And
so
sorry to interrupt, Chris, but I believe the booster is going down now.
nice.
It looks like it.
Got a great shot there of the ship quick disconnect there. You can see it's been mounted a little bit higher. It's been on a bit of a platform there, so it can reach the extra 2 meters higher.
I just want to spend 30 seconds on this. They literally just did that to cater for the extra height. Over at the Kennedy Space Center, Mobile Launcher 1 has different umbilical height connections with the SLS Block 1B. So rather than changing the umbilicals heights, they said we're going to build a new Mobile Launcher 2, for Block 1B, after building the Mobile Launcher 1 for Block 1. So literally, SpaceX's solution to an $800 million new mobile launcher is to put it on a booster seat like there and said, oh, we'll just raise it a little bit higher on the tower that way. Probably costs them about $1,000 compared to $800 million.
Yeah.
And that actually brings up a super chat question from Debbie Lynn, who says, I remember on the full stack, the lifting cable is very close to the top. With this added ring, is that going to put it to the max? And is this correcting that problem?
Yes, literally does. That's what they've done. We saw it being taken off. They took the entire piping and plate away, leaving just the arm. And when they took that off, they added those platforms. You can see on the left-hand side, the extra platforms, and then raised it up and then put it back on. And literally, that's how they've done it. They've just basically just changed where it'll attach the ship higher up on the entire stack.
I think here Debbie is discussing the chopsticks, the lifting mechanism, the drawworks.
Oh, I was still on the ship because we disconnected.
Yeah. I think it will put them closer to their max, obviously. Obviously, it's still within their limits because they have raised it. It's about 2 meters higher, it should be. It looks like they just took an ordinary ring and just cut the openings in it. So it should be about 2 meters or so higher now. But they definitely built some margin into the tower. We've seen SpaceX and Elon talk a lot about in the future possibly stretching the ship, making the ship longer for either more payload or more propellant, maybe making the booster longer as well in the long run. So you kind of need to have that kind of flexibility in your ground support equipment. And I believe, if I recall correctly, Adrian, you can correct me on this, but I think the tower at Kennedy Space Center is a slight bit taller than the one here in Starbase. I could be misremembering, but I feel like I heard that it's one segment taller.
It's the same height as far as we know.
Okay, yeah, Alex is correct, me, same height.
Yeah.
Okay.
And also, I want to quickly point out, I did my math.
Oh, good.
And doing upwards, the booster moves at about 2 meters per 30 seconds, or 0.25 kilometers an hour.
It looks pretty quick to me.
Blazing fast.
Yeah.
Yeah,
Look how
it's
fast
like
it's coming down.
I mean, that's still fast, right?
For something along these lines, lifting something 200 tons, a very delicate piece of rocket hardware, absolutely.
Yeah, and it's expensive too. Hey, we got a super chat here from Richard, aka Ethane Man, $100 tip. Thank you very much for your support of the efforts here from the NSF crew.
One of our regulars, by the way, is always supporting us. Again, everybody who's in, regardless, guests, first-time viewers, you're all numbers who help us push on with this, so you're all appreciated. But when you start noticing the same name over and over and over again, I think it deserves a little shout out there. So thank you to Methane Man there.
We really appreciate the support. It means a lot, and this team works incredibly hard. I'm the new guy around here, and I'm just so impressed with the dedication and passion for what's happening here at NSF. And it looks like we're getting pretty close to, shall we say, a mount?
Looks
Touchdown?
like it.
Touchdown? Yeah, what do we call it?
Looks like they have paused now. Either that or they're going extremely slowly. Looks like they have paused for now.
This is usually where they start to go very, very slowly. They will start to be very, very careful here because now they need to place these raptors inside these area with precision. And you don't want to bump your raptors now, right? You don't want to replace a raptor at that point. So yeah, they try to be careful here.
And while we are waiting, I have a question for Chris B from the chat about the shuttle.
Oh, really?
Shuttle, yes, from Eric. Eric Leith asks, shuttle-related question for Chris B. Are the Starship tiles the same composition as the shuttle thermal tiles?
Oh, it's similar. Again, there's some variance in it. The interesting thing was when we first saw the first TPS tiles being applied to a Starship, they actually used the same kind of color coding for what they deemed as good tiles, bad tiles, gap fillers, things like that. So it's very much a kind of heritage of the space shuttle. The actual composition of the tiles, I think, is different. And that makes sense because let's remember, Starship is designed for higher re-entry from its future targets, let's say from a Mars velocity. That's why Orion's heat shield is completely different to Space Shuttle. The Space Shuttle was designed for a 17,500 mile an hour return, and an entry interface would be slightly lower than that, but that's the kind of temperatures it was deemed to deal with. Whereas Starship will be looking to the future, and I'm sure there'll be some kind of Picker X, they call it, which Dragon uses for some kind of extra evolution, shall we say, of the TPS. So I would say it's different, but there are some similarities. Now, I was struck by, I actually did a tweet, I'll never be able to find it, but I did a tweet of, in the OPF, they showed the different color markers on the TPS post-flight of like which tiles needed replacing, which tiles were good, which tiles needed a gap filler. And they used the same kind of ribbons on Starship, and I thought that was wonderful. So there's some commonality, but the composition will be different, I would have said.
Chris,
of course,
sorry, Lon.
Go ahead.
I was going to say, to add on to your conversation there real quick about the tiles, Chris, there's, SpaceX has definitely learned a lot from the shuttle, and they've learned a lot from Dragon. But Starship and Dragon are using two very, very different heat shield systems. So Dragon, like you said, uses Pica X. Phenolic impregnated carbon ablator X.
Yes.
That is an ablative heat shield, whereas Starship is using Tough Rock, which is, toughened unipiece fibrous reinforced oxidation resistant composite. There we go. That is a reusable, composite tile that is reusable. It's based on a lot of the shuttle heritage, the black tiles on the shuttle. I forget the exact name of those, Chris. That's your department. But there's a lot of in common between the shuttle and Starship, but not necessarily Starship and Dragon.
Right. It looks like we're going for it here, folks. I see our engine bells slowly being lowered.
Oh yeah,
Here it comes.
that's that also was way shorter hold than expected. Like every single hold here. I mean, let me just reverse here from the moment they started to lift this, that's just about 30 minutes or so. That's
Amazing. Yeah,
quite impressive.
I think they're just getting the hang of it, right? It seems like you do it a couple more times, and it's pretty cool. Hey, I got another question here as we got a close look at the OLM here, and if we have to jump in for a milestone, let me know. But Alfredo Gallardo was wondering that the OLM looks more refined. It looks better than it did before. Is that the result of what they learned from their first launch, perhaps?
Oh, definitely. I mean, they've put some slight, refurbishments and upgrades into the systems here. Overall, the OLM is mostly the same after the first flight, or compared to what it was on the first flight. There were some upgrades put in and repairs. Obviously, the deluge plate on the bottom has been added, some additional plumbing here and there, but the overall structure is the same. If you want to look for upgrades, Kennedy Space Center's OLM ring, that definitely seems to have some upgrades, or the Kennedy Space Center launch pad overall has a lot of upgrades. Of course, that seems to be on hold now as they're trying to get, the first vehicle to orbit. But once they get that completed, it'll be kind of nice to do a bit of an A/B test there, on Kennedy Space Center's pad versus Starbase's pad. But yeah, there have been a few upgrades here since the first flight.
This is potentially the last time we see these Raptors before launch.
Oh, geez.
Yeah, it's a crazy realization.
Yeah, you feel nervous.
Also, it's
getting
important. It's important to note there's still some milestones to come, and they're important milestones towards this launch date. We think it's quite close now. That is, they need to do a spin prime test. We think they're going to do a spin prime test at least. That will be coming up probably soon, maybe even tomorrow. We'll keep an eye out for it with the roadblocks and the testing and things like that. And then a static fire test, if so, because that'll be something to hopefully validate it for launch. That'll be a static fire to validate for launch. And that's the important thing there. Ship 25 has already been validated for launch with its static fire test. So when that rolls out, they'll then do a full stack with a ship on top. They'll do a full stack cryo. That's what we fully expect from last time, just to validate his systems, including the pad systems, which is very important. And then we'll wait for the green light. We think the FAA and the long pole, but not too far off. So we'll keep an eye on that because it'd be the key thing for SpaceX saying. I don't think SpaceX will say the FAA says yes. I think the SpaceX will simply say we're going to target this date, and that means they've got the approval, and then we can start really looking forward to the second launch of this massive rocket.
And that is a question we got from a super chatter here. SA, is the launch date, do you think, going to happen on the 31st? Or I guess it's kind of up to how this next round of tests goes, right?
It's tight. Yeah, I think that's very tight. That is the earliest possible it'll launch. I don't see that achievable because everything needs to go right and the FAA needs to be sort of like already on board, I would have said. So I think that's asking a lot. But I am now extremely hopeful of September. And, you know, that is even with the caveats involved with little bumps in the road. I think September is very doable now. And I think Elon really wants it as well, Elon and SpaceX, because there comes a point where they know they need to ramp up the cadence. And I think the main thing is making sure everything's good, but they'll go for a launch without kind of dilly-dallying because they know they need to try and get another launch off this year probably, just to show to HLS, their big contractor with a multi-billion-dollar contract, to show that they are improving their cadence for what will be a very exciting 2024. And that's when hopefully they'll get a refilling test in as well. And that just keeps them on the timeline. I think Elon was slightly miffed by Jim Free's comments at NASA, who said that the biggest concern for the human landing system is Starship. And I'm sure Elon read that and went, what? Us? Right. Surely not. So there's some motivation behind that.
And there was some pressure too, right? Because, you know, as other nations start looking at the moon and people wonder when are we getting there? This is how we get there. So it's going to be, I think, a big part and a lot of pressure, I think, from the government back to the SpaceX to get this moving. Now, Adrian, how low is this going to go here on the mounting?
A bit more. This is not fully touched down yet. There's still some, like, this is really the very, very final stages where they are very, very careful, because now, as we said earlier, there are clamps that now have to be open, and they will place it there, and then the clamps will make sure that they are fixated on top of the OLM before the chopsticks then release the booster at some point. But that could be hours from now before the chopsticks release it. So we are definitely in the final stages here, but this is really like the part where it might go very slow.
Got it. And what are we looking for next? After it latches down, the chopsticks will stay attached until they're certain it's in a good position.
Yeah. Usually they will fixate it, make sure it's like fully validated, everything is good, and then we will see I think, correct me if I'm wrong, Alex, but I think usually we even see the booster QD connecting before the chopsticks open, right? So I think the booster quick disconnect will usually, like, okay, he's saying it depends. Okay, then I would misremember that. But I thought the booster QD would usually connect before chopsticks open.
And we have a super chat question I'm going to put up here. This is in regards to the flight. I don't know if Ian might be able to handle this one. Will we get a buoy cam or booster splashdown? And another question: when will a bingo card be on the store for puns? Do you think the booster will be big enough to see? So, really, was wondering: are we going to be able to see the booster come back down? Is there going to be some kind of buoy cam out there?
So, first off, probably no buoy cam. SpaceX may have support boats out there to watch it from a distance. It's not going to be anything close up. You might see it, several kilometers away. Again, that's at SpaceX's discretion. They could have a ship out there. They could not. Depending on how close it boosts back to land, and depending on, of course, what time of day, the weather and all that, you may be able to see it land from the ground here, from Starbase, from Boca Chica, depending on how, if it boosts back and lands just a few kilometers offshore. There's a lot of ifs and a lot of, maybes in there, but, maybe it'd be possible to see the booster landing from land here. And maybe SpaceX will have a ship out there to track it. We're going to have to wait and find out for any word from SpaceX on that one.
And Adrian, as I look at this shot here, I see some tanks that are pretty nicely dented up there. Was that the result of our first launch experience?
Yes, that absolutely was a result of the rock tornado, how we label it so nicely. So yes, the tanks are still dented. Although to point out, most of these tanks have an outer inner layer. Not every of these tanks have an outer and an inner layer, but most of these have. The only exceptions is the water tanks who don't need an insulation layer, but everything else there is basically that's what we see is just the shell. There's another tank in the inside. So let's see.
And it
Oh,
seems to be.
it's going down more.
Oh yeah, it is. They are moving
might-
really quick through this process. Certainly a lot faster than I've seen them do before.
They are.
Yeah, this might be the last move coming up.
This might be the last time Booster 9 moves until it lifts off under its own power.
Or the static
Holy
fire goes really funky.
Adrian, stop! What is with you manifesting things?
I'm
those,
not the one here at NSF who's the most guilty about that. See intro.
So, and actually, on that note, I've got a super chat question from Andrew. $9.99 super chat. Thanks for the coverage. Question for you all: probability in percent of reaching orbit if successful separation and Raptor ignition on Starship. Not to jinx anything.
I would say, okay, hear me out. This is let me cook here.
Let him cook.
Yes, I think actually quite high. The moment the Raptors on the ship are ignited, I'm actually not that worried about this anymore. I think if they get through a successful separation and Raptor ignition, which I think are the most, like, that's actually the most crucial part, I think then they will make it. I think the crucial part really is the separation and Raptor ignition, and also the booster flight until this separation. Basically, making sure you do not lose all that margin already during booster flight before the ship even gets to that job. But if they reach successful separation and Raptor ignition with still the margin to do it in theory, I think there's a high chance they will make it to their final target velocity.
What about you,
I
Ian?
would
What's the over-under?
Yeah, I would agree with it. I mean, I think once if they reach successful stage separation and all 6 Raptors light, I think it's very, very good odds that they make it to orbital velocity, which is their milestone. They're not trying to get to orbit. They're trying to get very, very close to orbit without actually finally getting into orbit. Now, I would say overall, like if we're talking about from liftoff from the pad, maybe like a 30% chance of reaching orbital velocity. But I think if they make it to stage separation, it's a given. There's a lot in play here. There's a lot of new stuff that they haven't tested through flight yet, like the electric thrust vector control system. The Raptors, too, are another big thing. That was kind of the reason that the last flight failed, was because so many Raptors shut down in flight. I think by the time it flipped, there were 9 engines down.
Right.
So...
And was a lot of that from the damage that it took on the pad as it was lifting off?
That I actually don't know. Adrian, I don't. If you know that one, let me know. But I don't recall anything about the Raptors themselves getting damaged from the concrete damage.
It's okay. It's a thing that basically I think they said it's not the case. However, it's always hard to pinpoint every single reason. I mean, there has to be a reason why multiple Raptors were out already. So
Definitely.
it's like, yes, it didn't damage the Raptors directly, but did it probably damage something that might be related to the Raptors at some point? It's a hard to answer question that
Right.
maybe even SpaceX doesn't fully understand. I'm
Yeah.
pretty sure they know a rock tornado is not optimal, but I do not think they can pinpoint like that single concrete took out one Raptor.
Right. It's hard to say with all that concrete flying around. It looks like the pins have deployed.
Yes,
Yes.
it looks like it.
They have guidance pins there that make sure that they also don't hit the pad while going down there.
It's interesting.
some
It's kind of like a training wheels there.
Yeah, right. And we got a super chat here from Dave Tracy. Thank you very much for your support. And let's see, I'll take a few more here. And Happy Cappy, are you late here? He goes, I'm thinking the only new thing to test is the higher SQD connection. Hope it aligns. don't know if
Yeah.
Ian could take that one.
That's definitely something they're going to have to, I guess, try out once they stack Ship 25. Again, we don't know when Ship 25 is being stacked. That is a while away, probably. But yeah, that's definitely, another thing on their checklist of things to look through. There's a lot of new systems on Booster 9. There are, even though Ship 25 was somewhat built as a copy of Ship 24, SpaceX has done some upgrades to it, some structural upgrades, I believe, and probably a handful of other upgrades throughout the vehicle from what they learned on Ship 24. So there's a lot of new things to test out here, and it's going to be a steady test campaign over the next few days and the next few weeks. They have quite a laundry list of things to get through.
Let me ask you this laundry list question from our store. we had those booster plushies, right? Is there a plan, Adrian or Ian? And I think Chris had to leave, so we're not going to get the answer from him. But there needs to be a hot stage ring accessory for the booster plushie. So we got to get on that.
Yeah, I don't think we will sell an additional hot stage booster ring add-on for this plushie. Probably in the future, and that's me knowing all the process that goes in bringing a plushie to the store. It's quite a long one, I can tell you. We will do more plushies in the future, and if the hot stage ring at that point is still a thing, it will be part of the plushie. But of course, yeah.
We'll
I mean, you
pray
could
for
3D
success.
print one.
You could make your own hot staging ring. Exactly. Yeah, so that might be a fun open source project for our fans to follow there. And speaking of that, we have another super chat here. Thank you very much to WTFII87 with a $49.99 super chat. We greatly appreciate your support today. And this was a fun stream because I haven't watched an entire lowering process here. This has been a great lesson in what goes into a pretty substantial rocket launch here. So this is just the first step of many to hopefully getting a big Starship stack off the ground. We have another super chat here from Jim Cavett, $5. Thank you very much. And Hone Gwyn, 2602, super chat. Thank you very much for your support of the channel. And Chazzy Mac here is volunteering a 300 millimeter lens for the landing, assuming weather cooperates, and we'll be happy to share it with the NSF crew. That'll be fun. See that come down like that.
Definitely.
Yeah. And let's see, we got another super chat here from Rankley. This is the first movie on crewed Starship, Rocknado versus Sharknado. There you go.
I don't think there's any winners in that one.
Oh, no, you could have like Sharknado come out of the Rocknado or something.
I don't want to see either. Can we just both not happening would be cool.
Right.
Yeah, given what happened in California recently.
Yes.
the hurricane.
Right. It was crazy out there. It's funny here in Connecticut, not to go off topic. We got a hurricane about 10 years ago or so. We had an earthquake here about 3 or 4 days before the hurricane hit us. Like a real earthquake. It was pretty crazy. I don't think that happens in Connecticut, but every once in a while it does happen. So, right. One more super chat here. I'm not sure if I don't know what he's referring to here. This is from Sahas, who wants to know what you all think about the 12-meter ship.
Not happening for a long, long time.
Yeah.
And what is the 12-meter ship for the uninitiated guy here?
So basically, the idea. So initially, Starship was bigger and had a bigger diameter back when it was still ITS, right?
Yes.
The transport system. So that, and then they shrinked it down a bit to the 9-meter diameter they now have. And the idea that Elon has mentioned in the past multiple times, if they ever upgrade, or if they will at some point upgrade or go to the next vehicle after Starship, that would probably be a diameter increase of the ship and the booster. So basically going from the 9-meter infrastructure they have right now to a 12-meter infrastructure. And I want to point out that might be in the future at some point, but it would mean a significant change of basically everything.
Right.
We are not talking about the ship and the booster itself. We are also talking about the mount. We are talking about lifting rigs. We are talking about basically everything that is used to build this. And this will not happen for a very long time, I think.
It looks like the stabilizer arms are out.
that means the booster is probably down.
Wow. That was a
If I-
very quick process then, if that's the case. Okay,
Awesome.
we got a question here from the chat from Dalen. Says, is the engine part of Booster 9 still powered by hydraulics, or did they switch to electric?
I want to quickly correct myself. It's the
Okay,
stabilizers
it's not
are not
down.
needed anymore. It's not fully down yet.
Got it.
And
A
I
little
also
ways
can take
through.
that. They removed the hydraulic pressure units, or power units on the booster. So usually that was actually a part that had a bit of a history of malfunctioning on Booster 7, because we saw them working on these hydraulic units multiple times and opening them and replacing them. So it was a bit of a tricky part, it seems. And the thrust vector control now on the engines has been replaced by electric steering. So that has been changed, and hopefully we don't have to see any more replacement of such a hardware, because it seemed, from what we can tell from observing Booster 7, that it was quite fragile. It seemed that part broke a lot. So let's hope that's not happening again.
Right, that's part of the testing. What doesn't work, throw it out and try something different. And we talked about chances of mission success, but Dalen's question, on the second part of his question here, what are the chances of stage separation working? I think one way or the other, it's going to separate with that hot that hot thing there. So what do you all think? Start with Ian.
Stage separation working. Obviously, that has not been tested in flight yet, but
Right.
it seems to be a relatively straightforward system. I think if they get to booster engine cutoff, stage separation is pretty likely, I think. Again, the hot staging is another unknown there. So there's a lot of things that they need to test during this flight that they either couldn't during last time or they've added since the first flight. So it's kind of tough here to ask odds when there's a lot of things in flux here, in my opinion.
Right, so we're still waiting on confirmation that we are down, but I think we're pretty darn close to being down.
Yep.
And just to recap, Adrian, what have we observed this evening? So the booster was essentially on the ground, and now it is on the OLM, right? So what's involved in because we came in right as it was getting lifted off, whatever it was resting on. So what's the process of getting this booster from where it is to there?
Yeah, it's kind of crazy if you think about it, that this booster was at the production site about 2 miles away or so, 7 or 8 hours ago. And now it's on the pad again. What went to this? They moved it to the Chopsticks earlier and placed it there, and then the Chopsticks grabbed the booster. The stand started to guide the booster up while the Chopsticks were lifting it. And then the boost was moved by the Chopsticks both horizontally and vertically over the launch pad and then lowered. And now the pad has initiated its guiding system with the pins, where the booster is being placed in the final adjustments before touchdown, you could say.
To get it all into place. And then the next step, let's say they keep it here, they're ready to go, right? The next step is to get Starship on top of that booster with the same mechanism. Is that how it goes, Ian?
Yeah, so once they're done with the testing profile on Booster 9, then they're going to use the Chopsticks to get Ship 25 up on top. Basically a copy paste of this process that we saw here today. That is going to be dependent on how long Booster 9's test process takes. Ship 25's testing campaign seems to be more or less done. So it seems that they're waiting more on getting Booster 9 ready to go. We know that they're installing some tiles on Ship 25, probably some minor crossing their T's, dotting their I's kind of thing. But all eyes now are on Booster 9.
I guess the next thing is the clamps on the OLM are going to go out and connect to the booster, but it's going to be hard to see that, I think, because it's kind of obscured by the OLM.
Yeah, it's the metal ring we see right now here is basically in front of that.
Right, it's blocking our view. We've got to get another
Yeah.
camera on top of that thing.
Yeah, well, below it or something. That would be a very
Right.
sad camera at launch, though. But until then, cool. Yeah. But next thing would be the booster being basically fully fixated on the OLM, and once that happens, then this lift is over.
And we'll
Yep.
see. And I guess those chopsticks will kind of clear out of the way once it's down, so we'll kind of know that's when we're ready to go here. And I want to thank Anthony Richards for a $20 super chat. Greatly appreciate your support here this evening. And we have a $1.99 super chat from Michael Oliver, who has a shuttle question, but did not. I don't think he can fit it into the chat. I'm not sure. So maybe somebody can look out in the chat room. Happy to take your question if we can get you to put it into the regular chat. We'll try to help you out. Right. So it looks as though things have moved along pretty smoothly this evening. And as was noted, this is probably the last time we're going to see those Raptor engines before they are lit, and this whole stack goes up. Hey, Ian, how do we secure Starship to the top of this thing? What does it take to attach it? Because you have to detach it at some point on the ride. So how do you attach something that securely but also have it break away?
You basically took the words right out of my mouth. So it's a complicated issue to figure out because, like you said, this needs to hold. I believe it's the 1,200 or 3,600 ton Starship. I think it's 1,200 ton or so. Fully fueled Starship on top of the booster. Hold it very securely throughout all phases of flight, but then break away and get the ship out of there. So it's kind of a bit of a paradox question. But what they've decided to do is to go ahead and use three kind of clamping mechanisms, or three clamps, really. Now, the booster there, right on top of the hot stage ring, it has those three attachments. They're like triangle-shaped attachments spaced evenly around the booster. Those are kind of locks that once the ship is placed down, those will hinge into place and lock and hold down the ship on top of the booster. That holds it down securely from liftoff up until stage separation, when those clamps will then need to unhook, kind of fold inward, letting the booster go, or letting the ship go, and letting the ship go on its merry way. So yeah, three triangular shaped hold down clamps are what they've chosen to go with on top of the booster.
A lot to do here, and it's going to be, and I think it's as they launch and they have successes here, they're going to be able to obviously see what's working and what isn't from these stage separations. I have a feeling, I didn't chime in before, but I have a feeling we're going to see a pretty successful launch here. I think in observing SpaceX over the years, there's often a lot of learning moments that are followed by a very big success, and it seems like they're feeling pretty confident here. So not too bad. So do you think, Adrian, are we going to see anything else tonight, or is the main action over with here?
We are probably through most of the big visuals. The next thing we would see is the chopsticks kind of starting to release the booster. That's like the next visual thing we will see, and also them, like usually what we see quite before that, which is kind of hard to spot, is once the tension on the chopsticks releases, basically, because they stop to hold it, and the most of the weight is now in the OLM, and you can basically see them no longer being bit bent down while holding the weight. So that's the next steps.
And we have another super chat here from Joe Rader. Will they attach a hot interstage test article to a ship, put it on a suborbital pad, and static fire to test the interstage shield? That's an interesting question. Ian, do you think you can handle that one?
That's a really good question. I've honestly been wondering that myself. As far as we know, that test is not necessarily on the books, but that doesn't really rule it out. We haven't heard anything either way, but that would be something very interesting to see. I would love to see that personally. And speaking of the hot staging ring, I think it's important to note that it seems like, based on the dome that they've put inside the ring, that only the Raptor vacuum engines are going to be igniting for the hot staging event. And then the sea levels would kick in after separation. But either way, a static fire of Starship on top of Super Heavy would be very interesting. And it's honestly making me wonder if they're going to transition away from ship static fires on the pad to maybe ship static fires on top of the booster in the future.
Right.
Kind of an interesting possibility, but also if they keep the current design, they couldn't fire the sea level Raptors. So I don't know how much that would be useful to them.
Right, because when you're at a much higher altitude with less atmosphere, your whole engine is a bit different, isn't it?
It is, yes.
And another $5 super chat here from John Klein as we're waiting for confirmation here. What has been done to upgrade the flight termination system? I don't know if, Adrian, you can handle that because there were some problems with the flight termination system on the first test flight, right?
It looked about that they, it triggered, and I think it took 25 seconds to fully terminate the booster, which is not optimal for a flight termination system. It should terminate the flight pretty quickly. They improved that by increasing the charges. There's more flight termination charges now on the booster.
So just more bigger explosion.
Yes, bigger boom, more better. Is I think the how Jack would frame it.
That's an easy way to solve a problem.
Yeah, it's like the charges were not enough to rupture the tanks. Well, then put more charges on it.
So that's
Probably
I was thinking about this too. Ian, you're talking about blowing up the rocket, obviously, with these charges, and I guess you have to engineer that. I guess you want the fuel to ignite to bring it down quickly, right?
Yeah, so the main thing is just to terminate the vehicle, stop it from moving. One of the ways that some rockets have an FTS more along the lines of shut down the engines and just stop it dead in the tracks, whereas others kind of have a thing of unzip the tank. In Starship's case, it's just get rid of the vehicle, destroy the vehicle, blow up the common dome, and just let everything go from there. Let some of the propellants mix and burn off, so you don't have liquid methane being either released into the atmosphere, which methane is a horrible, horrible greenhouse gas contributing to climate change. But also you don't want any of your propellants, falling on the ground and burning and bad stuff there.
Speaking of burning, Ian, when methane is burned, it's far less hazardous to the environment as it is when it's in its gaseous form.
Yes, it is. And that's why back in the days of Starhopper and the early Starship test vehicles, they had a flare stack where when methane boiled off inside the tanks, they would pump out the gaseous methane and burn it off, because carbon dioxide, which is what comes out of methane when you burn it along with water, carbon dioxide is a lot less worse of a greenhouse gas than methane. I believe methane is 4 to 8 times more potent, or I guess more greenhousey. I don't know that's the scientific term, but it's also why you see flare stacks at, say, landfills or at fuel refineries.
Right, where they're burning it off, right, to prevent the gas just from getting released. So there is a SpaceX mission coming up, but it's not theirs. They're doing it on behalf of a client. I think the Environmental Defense Fund has a satellite called MethaneSat that's going up soon. A friend of mine is involved with that. So that might be something to talk about in the future. That's going to look for those methane emissions. But the goal here is to have Starship burn all of its methane, so it doesn't emit anything but some fire out of its Raptor engines there. So have to be on the lookout for that. Hey, Adrian.
Yeah.
We have a super chat here for something that's coming up later this week. In fact, in the morning, I am flying down to Florida to witness this. Crew 7. Do you happen to know which Crew Dragon is being used for Crew 7?
Oh yeah, I'm. First off, I'm super excited for so many people at NSF to go to Crew Dragon, and I believe it's Endurance. It should be the third flight of Endurance, if I'm not completely wrong here. If I'm out of my head, but I'm pretty sure it's Endurance with the third flight. So yeah, going to be exciting. I love crew launches. It's also there's ESA participation in this one. So as a European, I'm like very excited for this as well because yay, ESA.
It's a very international mission, so it's going to be fun to watch that. It's always fun to watch astronauts leaving from the Kennedy Space Center after all these years of waiting for this to happen once again. And Ian, one of the things I noticed with the capsules or the Dragons that SpaceX launches is that although they don't power wash their boosters, they certainly give the Dragons a new paint job.
Yeah, so it's not just a paint job. Actually, real quick, I want to correct myself when I talked about methane versus CO2. Methane is 25 times more potent than CO2, so horrendous. And that's why they try to burn it off and contain it as much as possible. So just wanted to real quickly fix that there. But yeah, you're right. Dragons do look fresh after every mission, and it's not just a paint job. So on the exterior of Dragon, all the silver and white bits, those are heat shields. It's on the bottom of the vehicle, the silver part. Of course, that is the, on the bottom of the vehicle is the largest heat shield, the most important heat shield. But up the sides of the vehicle, there are kind of less potent, but still as important heat shields. And during Dragon refurbishment, they will take the heat shield panels off because they have ablated away. Like I said earlier in the stream, Dragon uses what's called an ablative heat shield. So as it heats up, it sheds small particles off the heat shield to get the heat away from the vehicle, gets rid of the hot particles to get the heat away. So because of that, the heat shield wears away over time. And as of right now, I don't believe the heat shield can be reused between missions. So they need to take all that paneling off during refurbishment and put all new paneling on. So that's why it looks really, really fresh between missions, whereas Falcon 9 looks, really used and really sooty, and it's been through hell,
Right. And the shuttle had always looked a bit weathered too, right? So it's always fun to see a fresh, new looking, used or flight proven Dragon up there at the top. Got all my spaceships mixed up here. Hey, we're probably gonna wrap here pretty soon, but I did want to acknowledge a few more super chats. Tim Atkins here. Let me get his chat up on screen. With hot staging, should we think of stage separation as the booster's max Q?
It would okay. That's a max Q is more defined on the whole vehicle. Booster max Q, I'm not sure if it would be also for the booster. For the hot staging ring, however, the most amount of pressure on that ring is probably right before the 33 Raptor engines start to shut down before at the bottom of the booster. Because as the booster gets lighter, more and more acceleration is pushing against the ring. So you would probably have that situation that it has the highest amount of stress on the hot staging ring right before separation.
And it looks as though Booster 9 here is very slowly being set down. So it looks like they're being very careful here as it goes the last couple of inches before they release those chopsticks there. But I think we're pretty safe to say I think we've had a successful mounting here today. I have one last super chat from Christopher Campfield, who says that the transport and stacking seems faster than the SLS. It is a very different process, isn't it, Ian?
It's very much an apples to oranges comparison, yes. Starship and SLS are extremely different vehicles, both from a vehicle design perspective, a ground support equipment perspective, launch hardware perspective. There's really nothing you can compare between these two vehicles. Of course, this process is quicker than SLS because SLS is using 60-year-old hardware and 60-year-old concepts for its vehicle construction. That's just because they're using what they have on hand at Kennedy Space Center. The VAB, the Mobile Launcher System, the crawler transporters were designed for the Saturn V back in the mid-60s.
Right.
Starship has been designed from scratch. So, of course, there's going to be improvements and efficiency improvements over time with Starship compared to SLS. It's not really useful to compare these two systems like that.
Yeah, they're very different, and they're going to be working together too, which is going to be fun to see. I always like that contrast of being down at the Kennedy Space Center and looking to the left there for 39B, and then seeing all the activity at 39A, and it's kind of a real example of just how much is happening here, and how uncertain I think the future will be. Although I think one thing is certain, that we're going to be going to space quite frequently as we are now. And as we're wrapping up here, we have a $50, just about 1 cent off, $50 super chat here from David Sukup for $49.99. We greatly appreciate your support as we are winding down our coverage this evening of the Booster 9 lift and lower. And I want to thank you and everybody who tuned in tonight for watching the next step towards Starship's development here. This was a lot of fun. Adrian and Ian, any last thoughts?
Just that I'm very excited for the next few days.
All right, so we are going to be heading down, so we will be doing that. And I'm getting some feedback from the control room that we should talk about the KSC flyover.
Yes, I totally. I want to make sure that people that have not watched it watch it, because I honestly think it's one of the best flyovers we ever produced so far. It's amazing. I love it, and it has some exciting news, both about a potential upcoming crew tower at the Cape, as well as, and you won't believe this. There's some very exciting news about New Glenn. So
Ooh.
make sure to watch both of that.
All right,
I really think it's worth to watch.
Good. Well, I'm going to tune in myself right after I wrap things up here and check that out. And I'm looking forward to seeing all of you in person for Cruise 7. It's going to be a very late night, but that's how NASA rolls, right? It's whenever the window opens is when you're going. So we're going to be back for Cruise 7. I'm sure there's going to be some other activity happening in other parts of the world here that you'll see on NSF. So stay tuned for all of that. And if you're not already, definitely subscribe to the YouTube channel so that you can be notified of future streams and hit that bell, all the things that us popular YouTubers say. So there you go. All right, everybody. Well, thank you all for tuning in this evening. And I've been having a lot of fun working with the NSF crew here, and we will be back before you know it. So have a good night. And it looks like Starship is all tucked in for the evening here. Booster 9, I should say.
And here we go. We have liftoff. Propulsion continues to be nominal.
RS-68 chamber pressure looks good.
Following up. Roger, Atlantis.
Water towers, fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. It's orange!
145! Oh my god! Oh my god!
Decollage. What is it? Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
Methane would be igniting in the flare, correct?